Part 3. Solve each of the following equation. Express all your answers in simplest radical form. Let's look at number 9. We have x minus 4 squared equals 20. So for this one, we have to use an inverse function. We know the inverse function of x squared is square root of x. So we'll have the square root of x minus squared equals square root of 20. Now, when we have the square root of a squared, it cancels out, so we're left with x minus 4 equals, when we're doing the square root, we have to make sure we have our plus and minus sign always. Radical 20. X minus 4 equals plus minus. Now the greatest perfect square that goes into 20 would be 4. So we have square root of 4 times square root of 5, because 4 times 5 equals 20. So we have x minus 4 plus minus square root of 4, it's 2, square root of 5. Now we add plus 4 plus 4. X equals 4 plus minus 2 square root of 5. And that's our final answer. Okay, number 10, we have x squared minus 8x plus 5 equals 0. And this one says solve by completing the square. So to complete the square, we have to find our b over 2 squared. We have b over 2 squared equals, our b here in this case would be minus 8 over 2 squared. Negative 8 over 2 is a negative 4 squared. Negative 4 squared is 16, positive 16. So we're going to rewrite this. X squared minus 8x plus 16 minus 16 plus 5 equals 0. Now I'm going to put a parentheses here and right here as well, because I know this one we can write it as x minus 4 squared. And then here we have minus 16 plus 5, which would be negative 11, equals 0. Now we're going to bring the 11 to the other side, plus 11. Draw your equal sign. We're left with x minus 4 squared equals 11. Remember, the inverse is to get the square root. When we get the square root, we left with x minus 4 equals, remember, plus and minus square root of 11. Now the square root of 11 can't be reduced, can't be simplified, because there's no greatest perfect square that will come out of there. So we'll leave it at how it is. Now we're gonna move over here. We have x minus 4 equals plus minus radical 11. Now we're going to add the 4 to the other side, and we're left with x equals 4 plus minus square root of 11, and that would be our final answer in simplest radical form. Number 11, we have 10x squared plus 11x minus 6 equals 0. Now this one is telling us solve by using the quadratic formula. So the quadratic formula is x equals minus b plus minus square root of b squared minus 4ac over 2a. Now we want to find our a, b, and c. So we have a, b, and c. That's our a, this is our b, and this is our c. So I'm going to write it over here. A equals 10, b equals 11, c equals negative 6. And I'll just circle this just for my reference. Now we have a, x equals minus 11, that's our b, plus minus 11 squared minus 4, our a is 10, and our c is negative 6 over 2, a is 10. Now let's reduce this, negative 11 plus minus. So 11 squared is 121 minus 4 times 10 is negative 40. Negative 40 times negative 6 is positive 240. So plus 240 over 20. I want to go this side. I'm going to go up here. Continue. X equals negative 11 plus minus square root. We have 121 plus 240, which would be 361 over 20. Now, x equals negative 11 plus minus. Now, the square root of 361, actually it's a perfect square. When you do the square root, you can do it in your calculator. The square root of 361 is 19. So plus minus 19 over 20. Now we're going to have a plus and minus, so I'm going to do the plus first. Negative 11 plus 19 over 20 equals negative 11 plus 19 is 8 over 20. We have 8 over 20. We can reduce this because we take out a 4 on both sides. We're left with 2 over 5. So that's one of them. And now we're going to do the other one. Negative 11 minus 19 over 20. Negative 11 minus 19 is negative 30 over 20. And negative 30 over 20, we can take out a 10, the top and the bottom, and we're left with negative 3 over 2. So that would be our x. Our x is negative 3 over 2. And x equals 2 over 5. That's all. Find our answer. 12. 12 we have 2x cubed minus 1 equals 53. Solve exactly. So we said that this one we have to use inverse as well. Now we know that the inverse of x squared is a square root. Now the inverse of x cubed would be the cube root. So let's find out. So let's do, we're going to add 1 plus 1 plus 1 on both sides. We're left with 2x cubed equals 54. Now we'll divide by 2 to get the x by itself. X cubed equals 27. Now the inverse of x cubed we said is the cube root. So do the cube root on both sides. Now the cube root cancels it, so we're left with x. and the cube root of 27 is 3. And that's our final answer. Alright, so let's go on to part 4. We have 3 response questions. So let's go to number 13. It says, graph the function f of x equals the square root of x plus 3 minus 1 on the grid below. Show the table that you created by hand or using your calculator, then state its domain and range. Alright, so for this one, let's use our calculators to help us create a table. So we have our calculator, clear, and what I'm going to do is I'm going to go to y, and I'm going to write in the function, which is the square root of x plus 3 minus 1. So I'm going to go here, second x squared, which is the square root, plug in x plus 3 minus 1, graph. So that's how our graph should look like. Now to create our table, I'm going to go second table, and when we look at here, we can tell that the values less than negative 3 is error, does not exist. So we know we can't use none of those. So it looks like here negative 3 would be a good point. Negative 3, negative 1, negative 2, and y is 0. I want to use these points because it's like the y is decimal. Let me use 1, x equals 1, y is 1. That's a good one to plot. And I'm going to continue down to x equals 6, which y equals 2, so I can use that point as well. And if I keep going down, our next point is 13, but I won't use that since our graph only goes up to 10. So, like I said, we're going to use starting at negative 3. So I'm going to take this out of here. I'm going to create my table. So we chose my table, my x and my y. So I'm going to choose negative 3, negative 2, 1, and 6. And looking at my calculator, I know at negative 3 it was negative 1, negative 2 was 0, at 1 it was 1, and at 6 it was y was 2. So I'm going to go ahead and plot these points on my graph. So the first point was negative 3, negative 1, point right there. Next point was negative 2, so negative 2, 0, so stays right there. Next point was 1, 1, and 1. And the last point was 6, so up to 6, and it was 2. So go 1, 2, 6, comma 2. Now I'm going to go ahead and connect my points. And notice that this is going to be kind of a curve. And put my arrow here because it does continue going. And I'm going to label this as f of x equals square root of x plus 3 minus 1. So that's how my graph looks like. Now, we're going to look at our domain. In our domain, we know that that's our x values. So our x values we see here on the x-axis. At negative 3, we have a point, but we notice that less than negative 3, there's no point, it does not continue, and if you remember on our calculator, it does not exist. So all the values less than negative 3 won't be in our domain, and it looks like all the values greater than negative 3 is on our domain, because there's a y value for each, and it continues. So our domain would be x is greater than or equal to -3. Now our range is our y values. Now look at our graph again on our y-axis. We see that the lowest point for the y is -1, and it doesn't continue going lower than that, so that's not in our range. Less than -1 is not in our range, and it looks like all the values greater than -1 is in our range, because it keeps going up. This one is 2, and if it goes up slowly, but it's still increasing the y values. So we know that at -1, all the y values greater than or equal to -1 would be our range. So we're going to write it as y greater than or equal to -1. That's our range. And that's our answer. (14) State whether the product of square root of 3 and square root of 9 is rational or irrational number. Explain your answer. So we know a rational number means that it can be written as a ratio or a fraction, and irrational is basically numbers that cannot be written as a fraction or a ratio. So we want to know the product. So when it says product, we know that we have to multiply. Product means multiply. So we're multiplying square root of 3 and square root of 9. So square root of 3 times square root of 9. The square root of 3 can't be simplified. That's already in the simplest form. So I'm just going to write it again as square root of 3 times the square root of 9 does equal to 3. So if we multiply these together, we get 3 square root of 3. Now, if we put this in our calculator, (3) square root of 3 gives us a number 5.196152423. I'm going to write that down. 5.196152423, which cannot be written as a fraction. So if it cannot be written as a fraction, this is a irrational number. Irrational number because the product cannot be written as a fraction. And that's your final answer. Alright, let's look at number 15. It says, Michael graphs the parabola y equals x squared plus 4x plus 7 and find that it has no x-intercepts. Explain how you can verify Michael's result algebraically by solving for the zeros of the function. Alright, so I'm going to highlight algebraically, because it wants to do algebraically, and solve for the zeros of the function. So when it says x has no x-intercepts, I'm just going to draw here an axis, x and y-axis, and just a parabola. So this is the x-axis. So x-intercepts means when it crosses the x-axis. So when a parabola intercepts the x-axis, it means that it has real zeros. So this one has real zero. This is just an example. However, we want to find that x squared plus 4x plus 7 has no x-intercept. How can we solve that? To show that algebraically, we must set the function equal to 0 first. So if x squared plus 4x plus 7 equals 0. To solve this, I'll use completing the square, but you could also use the quadratic formula if you like. So we have to find our b over 2 squared. In this case, b is 4 over 2 squared. We have 2 squared equals 2 squared is 4. So we're going to rewrite this as x squared plus 4x plus 4 minus 4 plus 7 equals 0. Now I'm going to put parentheses over here and our little arrows, and I can rewrite this x squared plus 4x plus 4 as x plus 2 squared, and then minus 4 plus 7 would be positive 3 plus 3 equals 0. Now we want to get the 3 on the other side, so we're going to subtract. We have x plus 2 squared equals negative 3. Now to get the inverse function of this would be to find the square root. And we have x plus 2 equals plus negative square root of negative 3. However, if we look at this, we have negative 3 in the square root. And we know that it's not possible to find the square root of a negative number. So it's not possible. So I'm going to write that right here. It is not possible to find a square root of a negative number. Which means the function has no real zeros, or slash no x-intercept. And that's how we solve algebraically. Alright, so let's look at number 16. It says, given the function g of x equals square root of x plus 4, determine the values of x that cannot be in the domain of g. So we want to find the values of x that cannot be in the domain of range, cannot be in the domain of g. So like we said in problem 15, we cannot find the square root of a negative number, so we know that inside the square root it has to be less than 0, because we want to find the values of x that cannot be in the domain. So if we make this less than 0, that means it will be negative, and we want to set it to be negative in here because that's the values that cannot be in the domain of g. So we're going to set it up as the inside of the square root is x plus 4, and we want the inside to be negative, so it'll be less than 0. Now we want to solve for x, so we're going to subtract 4, and we're left with x is less than negative 4. So it's saying here that all the values less than negative 4, it'll make the square root, the inside, negative. So that'll be our final answer. The values of x that cannot be in domain will be x less than negative 4. Because if we see here, if we chose a number less than 4, negative 4, a number less than negative 4 would be 5. So negative 5. So we plug in negative 5 plus 4, we get that's negative 1, which is not possible. So all values less than negative 4 cannot be in the domain of G. Now let's look at number 17. It says here, the graph of f of x equals absolute value of x is shown below along with the graph of g of x. Determine the equation for the function of g of x. So if we look at the graph, we have here, this right here is f of x of this equals absolute value of x. Now, right here, this graph right here is g of x. That's what we want to find the equation of. So we know it's absolute value because they're both the same, a broken line. So we know we want to see how much it is shifted. So let's see here. To get to here, it moved 1, 2. So shifted right 2. Now to get to here, it went 1, 2, 3, and went down 3. So I'm going to rewrite it up here. So from f of x equals absolute value of x to g of x, the graph shifted right 2 units and shifted down 3 units. Now to write this g of x, if we go back to what I posted for the rules for shifting, we would see that to move right 2 units, we would have to subtract inside the absolute value. We have absolute value x, and when we're going to the right, we're subtracting. So it would be minus 2 units inside of the absolute value. And when we're going shifting up or down, it's outside the absolute value. So when we're going down, we're subtracting. So minus 3. And that would be our final answer. G of x equals absolute value of x minus 2 minus 3.